Hello students, today we're going to talk about the two new types of quadrilaterals. The first one is a trapezoid and the other one is a kite. So let's first look at some key definitions. A trapezoid is a quadrilateral that has exactly one pair of parallel sides. This is what makes it different from a parallelogram whose opposite sides are parallel. The parallel sides are called bases. The non-parallel sides are called legs. The two angles that share a base of a trapezoid are called base angles. So here's a diagram of what that looks like. So this is any trapezoid in general. We have our base angles at the top and the bottom, the legs along the sides there, and indicated by the arrows are our base. When we have two legs that are congruent, we have an isosceles trapezoid. So here's a picture of an isosceles trapezoid. As you can see, the bases are still parallel, but the legs themselves are going to be congruent. There are some properties of trapezoids, specifically and these are specific to isosceles trapezoids. The first one is that each pair of base angles are congruent. So when we're discussing this, what you need to pay attention to is where these base angles are. So we're looking at one of the two parallel sides. The two angles that are consecutive right next to it are the ones that are going to be congruent, as well as the bottom ones are going to be congruent. The other thing is the diagonals are congruent. So now we can remember when we did rectangles, their diagonals were congruent, but these are not parallelograms. So these are something a little bit different, but it's the same idea. So what we have there are two diagonals that are congruent. Continue on, in general, any trapezoid, if we have any kind of trapezoid, this is going to happen, these next two properties. The first thing is, if I were to draw in a mid-segment, so remember mid-segments are where we connect the two midpoints of the legs, they're going to be parallel to both of those bases. So that's our first property. The other one is the length of that mid-segment is the average of the lengths of the bases. So in this specific example, I would add the values of RA and TP, those lengths, and cut it in half, and that would give you the length of MN. So it's exactly half the average. So let's do an example with that. What I want to do first, if in this isosceles trapezoid here, we want to find the missing angles. So the first thing I know, since it's isosceles, that means the base angles are congruent. So angle C has to be congruent to the measure of angle F. So now what we want to do is find the measures of angle D and E. Well, keep in mind that these are parallel lines at the top and the bottom. So what we can assume now is that angles such as D and C, or angles E and F, they're going to be supplementary. So the measure of angle E and F are going to add up to 180, and C and D are going to add up to 180. So since both C and F are 65, I can replace those two angles with a measure of 65, and then I can solve. In either case, angles E and D are equal to 115. Let's take a look at another example here. We want to find the measure of the base angles given the triangle is one of 20 isosceles triangles. So this actually is a picture of a fan here. We're focusing in on one of the isosceles trapezoids that are going to be drawn in here, looking at one also isosceles triangle. So what we can do first is find the measure of angle 1, indicated here at the very top by the angle and the arrow. So since there are 20 of them in there, we can take 360 and divide it by 20, and that's the measure of the angle at the top, which is 18. So now what I can do is find the measure of x. Since it's a triangle, and it's an isosceles triangle, those two angles are going to be equal to each other. So what I can do is take x and x, again, that's going to represent the x at the top there, or on the bottom left, and since the isosceles triangle, it's also going to be the other one, and the angle at the top. So if I go through and solve using algebra, I found the value of x is equal to 81. Well, now we're going to then be focusing on y, which is part of an isosceles trapezoid. We can make this assumption because it is a piece of an isosceles triangle. So what we know here is that since it's an isosceles trapezoid, that those two angles have to be supplementary. So 81 plus y is equal to 180. So the measure of angle y is 99 degrees. Let's do our last one here, this last example for trapezoids. And we know that the segment QR is the mid-segment trapezoid LMNP, so we want to find the value of x. Well, now we're going to go back to that relationship where the mid-segment is half the average of the other two sides there, the parallel bases. So let's set it up in general. The QR, which is the mid-segment, is equal to 1/2 of LM plus PN. Now that we know that much information, we can substitute in our pieces here. So x plus 2, which represents QR, is equal to 1/2 of 4x minus 10, which represents LM, plus 8, which represents PN. Combining our like terms inside the parentheses, I end up with 4x minus 2. At this point, you can either multiply both sides by 2, or you can distribute the 1/2. I'm going to go through and distribute the 1/2 because both of the numbers inside are even. What I end up with on the right side now is 2x minus 1. Finishing the problem up, I'm going to move the x to the right and the 1 to the left, and I get x is equal to 3. Let's talk about the last quadrilateral, which is a kite. The definition of a kite is it is a quadrilateral with 2 pairs of consecutive sides congruent, and no opposite sides are going to be congruent. So as you can see from the diagram here, we have 2 sides that are right next to each other congruent, marked by the single tick mark, and the 2 sides right next to each other with the 2 tick marks, because that's what consecutive means, one right after the other. There are no opposite sides going to be parallel to each other at all. So now let's look at some properties. The first one we have here is that diagonals are perpendicular. So if I were to draw the diagonal from A to C and B to D, we're going to find a couple of right angles. So here's a couple pieces of important information for you to remember. The first thing is, since segment AB is going to be congruent to segment AD, and we know that segment AC is perpendicular to segment BD by what we just discussed, by the perpendicular bisector's converse, we can make the conclusion that BE is congruent to DE, or in other words, that E is the midpoint of segment BD, right in the middle there. So from that now, we know that triangle ABE is congruent to triangle ADE by side, side, side. So this is very important for us to remember. If we were to find information about triangle ABE, it's going to match for triangle ADE. The same thing is going to happen with the longer triangles on the right. Triangle BEC is going to be congruent to triangle DEC. And finally, the main triangles ADC is going to be congruent to triangle ABC. Let's go through the last couple of examples. We first want to find the measure of the angles of a kite. So let's look at the obvious one. Since it's a kite, we know that the diagonals are perpendicular, so we can easily find the measure of angle 1. Angle 1 is going to be 90 degrees. Well, now that I know that angle 1 is 90 degrees, and I know the measure of angle there is 52 degrees, I can use the fact that it's a triangle sum, and 180 minus 90 minus 52 is equal to 38. So finally, I'm going to find the measure of angle 3. To find the measure of angle 3, I'm going back to that idea where I have 2 congruent triangles up there, so that measure is going to have to equal 52 degrees as well. We can continue by filling in the flow chart here. I'm going to go through it real fast. If you would like to fast forward through this and fill in your flow chart as you would like, I'm just going to be filling in the properties of the different types of trapezoids and kites. The one thing I want to make sure I pointed out to you is the right trapezoid. The right trapezoid has 2 right angles, one on each of the bases. A right kite is a one that also has a right angle in there. You can see it's on the left and the right angles there between the 2 consecutive sides that we see. So please pause this now and fill it in. The last thing you need to do is access the worksheet under the classwork section, not the casework, the classwork section. Determine each of the angle measures based upon what you have learned about trapezoids. I have provided you with a slip of paper for you to use as a diagram. See you tomorrow.